This is a short but more advanced tutorial for Indra system that focuses mainly on dealing with user-defined props, as we'll dig deep into the code on all the places that you can customize for parameters. We'll also introduce the front-end interface for Indra system. If you only want a general walkthrough and how to create an ABM from Indra, please watch our general tutorial video, which will also cover the basics of handling props. But in this video, we will present further details. In a high-level overview, it is rather simple for you to have a basic use of handling props. There are only a few steps. First, write all the parameters you need in the props.json file in a fixed format, which I will show you sooner. Second, call super.handleProps to initialize self.props. Third, retrieve the value of the parameter by getProp with the name of the parameter as input. Then you could set attributes in your struct or group if further processing on the user enter parameters is needed, such as this line of code about the value of red group. Handling props is basically setting values of the parameters in the model. In Indra system, you are asked several questions to set parameters when you run the model in the terminal mode. Parameters and the questions are defined in the props file. As I've just mentioned, there is a fixed format to organize props file. So before getting to the code, let me show you one example. Let's have a look at the props file of segregation model. It is organized as a two-layer dictionary. The key of outer dictionary is the parameter you want to set for your model, and the value is an inner dictionary with attribute value mapping. For inner dictionary, first, you set a default value of the parameter, or in other words, the fallback value of the parameter when you press enter button in the terminal. The attribute name is val, and we set a default value 40 for grid height. The second attribute is question, which is the question you design to ask in the terminal. It's better to compose a clear question since the parameter name itself might be confusing. The third one is A-type, which defines the data type of the parameter. There are several options. int stands for integer, dbl stands for double, and bool stands for boolean, while str stands for string. And the last two attributes, high val and low val, which defines the highest and lowest value of the parameters, are for numeric types int and double. You can set these two attributes based on the specific restrictions in your model. Now we have a basic understanding of the props file. Let's begin exploring the code to figure out how exactly handling props deal with props files, and if there is any other way to set parameters. I will explain while going through the code step by step. On the whole, handling props tries to initialize self.props in the model so that users can set multiple parameters with get in some complicated ABM models. To achieve this goal, we'll call a helper function handleProps, and we'll make use of the function createProps in the side package called propsargs. There are actually lots of details along the way. I'll talk more about the key points and briefly mention details. Let's get started. Since all of our model classes inherited from the base class model, we first call super.handleProps defining the base model. Props is a dictionary of parameter name to value mapping. We'll leave it for now and talk about it later. Let's step into it to see what's going on. First, we retrieve the user type from environment variable. If the function is called from API, we'll skip setting the question. Otherwise, we'll have question set on the terminal. Next, we'll call initProps to set self.props, which is what we will mainly talk about. After that, we'll get height and width here, since almost all the models get used them. In initProps, we'll call the function createProps. There are some parameters. Model directory is the path of the model, and model name is the name of the model. They're used to generate the path of the props file. Prop is the dictionary of the parameters I just mentioned. Skip user question is to set whether we need to generate questions in the terminal. Okay, let's move on. In createProps, we'll initialize an instance of class propArgs and return it. There are two ways to initialize self.props, from a file or from a dictionary. If we pass a props file, we'll call json.load first to convert the content of the JSON file into a props dictionary. Then we call setProps from dict to retrieve the values in the props dictionary and put them into self.props. If we pass a props dictionary, we just call setProps from dict to put values into self.props. Remind that if we pass both props file and props dict, values set by the file will be overridden by the values in the dict, since values in the props dict is set after the props file. So inside this setProps from dict function, for each parameter, we ensure the attribute value to be the same type as the input A type. We simply retrieve the value of all other attributes and initialize an instance of class prop. After that, we'll finally get the properties. Now we can start to get values of the parameters. Up to now, I believe you have got the spirit of how handle props works. Let's move on and see its effect. Last time in the general tutorial, we present how we can specify parameters with user questions in the presentation of forest fire model. But we simply set constant values for the parameters in the transformation from basic model to segregation model, since it's more straightforward to set parameters. After all the explanations above, it's a good time to put it into practice and see how it works. If we don't want to assign a constant value to a parameter, but rather from a configurable file, and maybe even compute values for another properties, this will be the perfect approach that you are looking for. Here, for the blue group members and red group members, we don't want a constant like 200 that is fixed, but a formula to calculate it based on the blue density and red density parameters we specified. If we choose to run for n periods in the menu and run for 1 period, we can see the blue and red members are no longer the 250, which we specified as the default value. So we get value from the density value times the area, which is 0.33, the default density value times by area, which is 40 squared. This computation will get the blue or red members that we got now, that is 528. We can also get rid of the handle props function if you don't think this kind of computation is needed for your parameters. In that way, the blue members and red members will use the default value that we specified earlier in this file, which is 250. Besides running your models through terminal, we also have a web-based front-end interface to show our ABMs. You can see it directly from here that we have a drop-down menu for the users to select a model. Those models can be pre-populated from configuration, which means you can have your own customized model to be shown here if you want. If we proceed with selecting the forest fire model here, our page will show us 4 questions that are the same as the question as we will get from the terminal. These questions are read from the same configuration file, which is the props file. You can see in the input box, we have the default value in gray, like grid height and width, which should be 40. If you do want to specify a value, we can type in the input box just like we will type in a customized value in terminal before. Here we can see a more visual-friendly graph than the one on the terminal. We have the output from the terminal in the section of model status shown on the right, as well as the scatter plot at the bottom. Basically, we keep the workflow consistent throughout both terminal and web. So this is just a brief overview that we have the web option to show the models. So this is a video tutorial that focuses mainly on handling parameters. Please feel free to contact us if you have any questions. Also, feel free to comment or start an issues track on the specific topics that you want to dive in. We may consider producing more of those short video tutorials if those helps.